Everybody, pull up section 5.1. We're talking about using fundamental identities. We will use this chart and the one on the next page continuously for this chapter. You are not going to be expected to memorize any of this stuff. If you're in class and we have a test or quiz, I will give you these identities. At home, you can use them. The first part of your web assign today is going to say like sine u. What is sine u? Sine theta, sine whatever. What is that the same as? 1 over cosecant. You're just filling in the matches. What equals what? In this section, it is very important, guys. If it says sine of u and the u is lowercase, you have to have a lowercase u in WebAssign. If the trig function, you have to have lowercase letters. It's really, really touchy with that stuff. The more we use this, the more you guys see this, the easier it's going to get. And I promise you, you'll see that. Like every time you guys see tangent, a lot of times you'll remember, oh, it's sine over cosine. Cotangent, cosine over sine. They're just identities that you need to be familiar with. These ones here, called the Pythagorean identities, you're going to use those a lot. If you notice in the Pythagorean identities, what is happening to the trig functions? They're all what? They're all squared. That should give you a hint, like, ooh, I may have to use one of those Pythagorean identities because they're squared. But these things will be given to you, I promise. You're just going to have to know how to use them, because they mean nothing if you know how to use them. Again, these are just some more identities. The only thing you're really going to have to do with these is today on your web assign, just match what goes with what and plugging it in. We're not going to do much with those identities as far as proving and stuff. So let's look at this first example. This is a reminder from yesterday. Seems like yesterday, doesn't it? From what we did when we were last in school. Right? I need to find all 6 trig functions. When we talked about our trig functions, what 3 letters did we use? What did we have to find? The what, and the what?
ABC.
Okay, but in trig, we didn't use ABC. We used
X, Y, Z.
X, Y, and R. Okay? So we're going to use that, and we're going to use our all students take calculus to figure out the signs of our x's and y's and to then be able to find all 6 trig functions. So the first thing I'm going to look at is secant u. Secant goes with what? Cosine. Good. So think of that, secant and cosine. Cosine is what over what? Y over r, x over r?
X over R.
Okay, cosine is x over r. So they have given me what when they give me secant?
They give you the X and the R.
Okay, but what over what?
So it's 3 over negative 2.
They gave me r over x. All right, so what do we know? What should we always remember? R is always what kind of a number?
Positive.
R is always positive. So I know that my r is 3. What is the value of x?
Negative 2.
Negative 2. Does everybody see how we figured out where that negative sign went? All right, now they're telling, we have to figure out what quadrant this angle's in. So they gave me some information that I can use. Remember, all students take calculus. This first parameter that they gave me right here of the secant goes with cosine. The secant value is negative. So which 2 quadrants can I cross off? Because I know that secant or cosine is positive in those 2 quadrants.
First and second.
First and fourth. A and C. Everybody remember that? Okay. The second thing they tell me is that the tangent is what? Greater than 0. That means it's positive. So in the 2 quadrants that we have remaining, where is tangent positive?
Quadrant 3.
Quadrant 3. So I can cross this off. Now, some of you are saying, well, what's the big deal? Why do we need to do that? Think about the x and y values. If I had a point right here in quadrant 3, the x value is negative. What's the y value?
Also negative.
Also negative. If you guys didn't go through and figure that out, you would have used the Pythagorean theorem, found out what your y value was, and it would have been positive. And then when you did your trig functions, 4 of them would have been wrong because the sign wasn't right. So that's why we have to go through that progression. Take the first thing that they give you, cross off 2 of the quadrants, take the second thing, cross off the last one, and then you can figure out where this angle lies. Now that we know that we're in quadrant 3, now we can just do our Pythagorean theorem. X squared plus y squared equals r squared. So I have negative 2 squared plus y squared equals 3 squared. What's negative 2 squared?
4.
4.
4.
Plus y squared equals 9, right?
Mm-hmm.
Subtract so 4 from both sides, and I get
5.
y squared equals 5.
Y squared equals 5.
So what is the y value?
Negative root 5.
Yep.
Or here it's root 5, but then up there it's...
So these are the values that I'm going to use now to find all the trig functions. But again, if we didn't go through that first little bit, we would have had our signs wrong on the x and y. That's what makes it so important that we do that. So sine, let's remind ourselves, sine of theta is y over r. Cosine theta, x over r. No, just leave it. So tangent of theta is going to be y over x, right? So our reciprocals, cosecant theta is going to be r over y. Secant of theta is r over x. And cotangent of theta is x over y. Correct? So now we just take those values and plug them in. So sine is y over r. It's going to be negative root 5 over 3. So then my cosecant would be 3 over negative root 5. That is okay for WebAssign, yes? Is it okay for Mrs. Meadows? No.
No.
So we got to rationalize. So this would be 3 root 5 over 5, and it's negative. Doesn't matter where you put the negative, just as long as it's there. So I have x over r. What's my x value?
Negative 2.
Okay, so it's negative 2 over 3.
Yep.
So my reciprocal would be?
Negative 3 over 2.
There you go. And then we have our tangent and cotangent. So y over x, root negative.
Radical. So it would be positive. Radical
Correct.
5 over 2.
Negative radical 5 over negative 2. If you guys left it like that, I would take points off. Because a negative divided by a negative is a. There you go. And then when I have my reciprocal over here, negative.
You're going to get 2 radical 5 over 5.
Yep, we're going to rationalize. 2 negatives give me a positive, so it's 2 root 5 over 5. Okay, that was just a little refresher on what we're doing. So for your WebAssign tonight, you guys could get it done right now. It's just using your identities, just filling in the identity, the equality statements, and then you have like 2 or 3 of these because you'll have this on a quiz. Sure. All right, again, after I go through this one problem, some of you are going to be looking at me like a dog that hears a real high-pitched sound. You know, you like cock your head real hard and you're like, what? Okay, I understand that. The more we practice this, the easier it'll get. There's no equal signs here. You guys are simplifying. When it says to simplify, remind yourself that there's going to be lots to do. Okay? Simplifying means there's a lot to do. Maddie, you can go whenever you need to. If you have to simplify, you're making things smaller. Do you guys see how, just look at this. Do you see how there's 2 different trig functions in this problem? Sine and cosine squared. Everybody see that? All right. We're going to think algebraically as we do this. I could also look at this kind of like x times y squared minus x, right? They both have a sine of x. You guys see how I just kind of in my mind thought that? So if I asked you to simplify, what would they both have in common that you could take out? They both have an x. Okay, so this is what we're going to do. When we talk about simplifying, we're trying to make this smaller. If you can, try and make it all the same trig function. So we're going to go through this together. I'm just rewriting the problem. And the first thing I'm going to do is, do you notice how in the first term there's a sine of x, and in the second term there's a sine of x? Everybody see that? Okay, so I'm going to take that out. I'm going to factor it out front. And when I divide out sine x, I'm left with cosine squared x minus what?
1.
Minus 1.
Okay, good. All right. Now we're trying to simplify. We're trying to make this smaller. I still have two different trig functions. Now, go back to your identities. Scroll back to your identities. What did I tell you about the ones that are squared? What are those ones called?
Pythagorean.
Pythagorean. Is there a Pythagorean identity that involves sine and cosine?
Yes.
What is it?
Yes. No, well, sine and cosine squared.
Okay, that's okay. So it's sine squared plus or minus?
Plus
Okay.
cosine squared.
Plus cosine squared x equals what? 1,
One.
right? So looking at this blue one, can I manipulate this formula so I can make the cosine squared of x equal to something in terms of sine? What would I do?
You can do. You can subtract sine squared x from both sides. and
Okay.
make Cosine.
Let's just do that. Sometimes it's good to write stuff down. And sometimes it works and sometimes it doesn't, but it's good to kind of see. So if I did this mathematically, this would work out to cosine squared x equals 1 minus the sine squared of x. Or you could have said negative sine squared of x plus 1. Does everybody agree with that? That mathematically makes sense. We just move the sign from one side to the other.
How do you get the sine squared stuff like that?
If I was simplifying this, guys, can I rewrite cosine squared of x in terms of sine squared? Those two things are equivalent now. They are the same thing. So I can rewrite, I still have my sine x outside. And then instead of cosine squared of x, I'm going to replace that with 1 minus sine squared. And then I still have the minus 1. So all I did was replace cosine squared of x with this. We just took one of the identities, moved it around. Now we're getting simplified. You can see because instead of two different trig functions, we now have what trig function? Just one. There's sine. Inside of my parentheses, hang on, inside my parentheses, what can I do with 1 and negative 1?
You can cancel them out.
I can cancel them out. So now I have sine x times negative sine squared of x. What does that give me?
Negative sine
Negative
cubed
sine
x.
cubed.
Negative sine cubed of x. And that is simplified. Some of you are going to say to me, how do I know I'm done? Well, check your identity sheet. Is there anything on the identity sheet that says anything about sine cubed of x?
No.
No. Do I have everything condensed into one trig function? Yes. All right. Now, again, I know some of you are like, what? And that's okay. We're going to practice this a bunch. We're going to practice this all week. And some of you are going to get better at it. Some of you just may never get the swing of it. And, you know, that's okay. You're going to try. But I cannot, you guys aren't all going to get A's on this test and quiz. It's just not going to happen.
Is this going to turn into like condensing and expanding, or is this just simplified?
No, you don't, it's not the same as logs. We're going to verify, which would be like proofs, starting Wednesday, and then we're going to solve these equations next week.
Okay.
Now, look at number 3. I'm just going to do number 3, and then I'm going to stop. We'll pick up tomorrow. If they say to factor, this looks incredibly difficult. This is actually super easy. You're going to want a bunch of these on your test. If they say, excuse me?
Perfect squared.
Yeah, it is. Just Vincent, don't steal my thunder, honey. This is my big time to show. I'm just kidding. You're fine. Think of this like factoring. So think like normal factoring, we'll call it. I don't know really what's normal, but. Okay? You don't have to do it this way. You don't have to do it this way. But it's helpful for some of us, I think, at the beginning to kind of see things. What I want you to do is I first want you to replace your trig function with x. All right, the second thing I want you to do is I want you to factor like you normally would. And then the third thing is you're going to replace the x with the trig function. Now I know some of you are like, well, that sounds silly, like extra work. I'm telling you for the beginning, it's easy to see things if you do it this way. I have my first problem is secant squared of theta, minus 1. I don't have any equal signs or anything like that, so I'm not solving this. I'm just simplifying. So I'm going to replace secant squared theta with x. So this is the same as x squared minus 1. You see what I did? I just took that whole trig thing and just replaced it with an x, just so I can see it. Now, if I was going to factor this, what would this factor into?
Secant theta.
X plus 1, x minus 1. You guys agree? So then the third step, it says to replace the x with the trig function. So I'm going to now rewrite this. Instead of x, I'm going to say secant of theta plus 1 and secant of theta minus 1. How come I didn't write secant squared?
Because you factored it down.
Correct. Because if I wrote secant squared and then secant squared, I'd have secant to the 4th. It's just a normal factoring problem like you guys have seen a million times. It just has trig functions. Now, some of you are going to be like, well, can I check it? Absolutely. Watch. If I write this out, secant theta plus 1 and secant of theta minus 1. FOIL. Secant times secant. Secant squared theta. Secant times negative 1 is minus secant of theta. Secant times positive 1 is plus secant of theta. And negative 1 and positive 1 gives me negative 1, right? What happens to my negative and positive secants?
They cancel out.
And then I'm left with secant squared theta minus 1, which is that what we started with?
Mm-hmm.
Yep. So this would be your answer. What's up?
All the writing in yellow is just checking.
That's just me showing you that how it works. Yeah. What I have boxed in purple is what your answer would be.
Okay, thank you.
All right, let's try the second one. Then I'm going to let y'all relax for a minute. I have 4 tangent squared theta plus tangent theta minus 3. So let's rewrite this in terms of x. What would it look like?
4x squared.
Okay,
Plus
4x squared plus x minus 3. Does everybody in here know how to factor that? Yes. 4 times negative 3 is negative 12. So I need factors of negative 12 that multiply to give me negative 12, but add to give me 1.
4 negative 3.
So x plus 4x minus 3. And since my a term is not 1, I'm going to divide each factor by that a term. So I'm left with x plus 1. And then does 3/4 divide pretty? No. So this becomes 4x minus 3. And now I'm going to rewrite it using my trig function, which was what?
Tangent.
Tangent. So I have tangent theta plus 1. What is my second parenthesis?
4 tangent theta minus 3.
4 times tangent theta minus 3. And if I FOIL that out to check it, tangent theta times tangent theta gives me tangent squared theta. Tangent theta times negative 3 is negative 3 tangent theta. 1 times 4 tangent theta is plus 4 tangent theta. And 1 times negative 3 is negative 3. So I have,
Miss Meadows.
I forgot the 4 in front.
I got the 4.
Yeah. So I have 4 tangent squared theta. What happens with a -3 and a +4?
It becomes just 1
Good.
tangent.
Is this what we started off with?
Yes.
Yep. So there you go. The factoring, really and truly, it looks hard, but those are going to be the ones you want more of. The next 3 examples I will do tomorrow.